Welcome to my channel. Today let's solve at the lead code question. The description of the question is fairly simple that we were given an integer n. We need to return all the numbers in range 1 to n sorted in lexicographical order. So let me just write some note points. We need to sort all the integers in the lexicographical order. And we must write an algorithm that uses O of n time. Algorithm time should be O of n and space should be O of 1. So we need to write an algorithm that runs in O of n time and uses O of 1 extra space. So given this, first of all, let me just try to explain what lexicographical order is. So by arranging in lexicographical order do mean that the numbers with the digits at the lower index value should be coming first if the number at the digit is smaller. So in the other way, if I just wanted to find out the lexicographical sorting of 10 and 2, then 10 should be coming first followed by 2, because if you just consider this index wise, 1 is at 0th index, 2 is at also 0th index, and here 1 is less than 2. So no matter what the next number is, as 1 is less than 2, so 10 would be coming first and followed by 2. This is same as dictionary order, right? In dictionary, no matter what the word is, like if we just consider these words A, B, C, D, and A, D, D, C, something like this kind of, only first character would be checked. So B is lesser than C, so this would be coming first. And in a similar way, if we just consider the numbers 258978 and 25897, I'll just call it 25898. So in this case as well, as 7 is lesser than 8, this would be coming first and then followed by this. I mean, I just mean to say this is not actually the greater than or lesser than comparison, but ideally we are just checking the digits here. And we just need to generate all the numbers that are lesser than n, lesser than or equal to n, that are in lexicographical order. So I'll just try to explain how this works. As I already told you, so let me just give you a brief. So let me just call you this as root. So all possible numbers like 1, 2, 3, 4, 5, 6, 7, oh, sorry, 7, 8, 9. I knew that these are all my possible digits, right? In a number from 1 to 10. So if I just wanted to process 2, so before processing 2, as I already told you, that we need to process the numbers that are lesser than 2, which are at the similar index. In the other sense, I'll just say, so if 1 with 1 I could find 10, 100, 1000, 10,000 and all, right? So these are obviously lesser than 2. So what I'm trying to say here is, so if I just found a number that is multiple of 10 of a current digit, like 10, here multiplied it with 10. So I'll just remove this all. So if I just multiply this with 10, and if that number is lesser than the limit or the upper one that's provided to us, then I need to push this number first before processing the next number, right? So that should be the case. And if 10 is also done, and if, for example, my 100 is also within the list itself or within the bound itself, if 100 also within the bound, then 100 should be processed first, followed by the next number, as I already told you. So after 10, what I would be getting is 11, right? So 11 is by default in lexicographical order greater than 100, because here at the first index the value is 0, here at the first index the value is 1. So before processing 11, I need to process 100. So I'll just keep on checking if my current number multiplied by 10 is within the bounds. If it's within the bounds, then that should be the answer. If that's not within the bound, then what I'll do is I'll just traverse back, or I'll just retrace, and then after retracing, I'll just add one number. I mean, from 1 to 9, or if I just consider from 1 to 9 numbers, I'll just keep on adding one digits. Like first, I'll process 11, and then 11 into 10 would be 110. I'll just check that within the limit. If that's not within the limit, then I already added one, that state would be maintained. So in the DFS call, so after 11, it would be 12, and so on. So I'm pretty sure you might have understood what I'm trying to say. So I'll just write what I'm saying here. And first of all, I need to maintain the state array that's to store the answer, and I'm calling it ans. And I'll just call in cur, which gives me current number, and in 10, which is the limit. If cur is less than, sorry, if cur is greater than n, then I'll simply return. And if it's not, then ans dot pushback cur. I'll just push back cur helper of ans cur. So here I'll just check if my cur into 10 is less than n. If my cur into 10 is less than n, then only I'll just say helper of, or I'll just check less than or equal to ans dot push, sorry, ans cur into 10 followed by n. If it's not lesser than or equal to n, what I'll say is else for int I equal to 1, I is less than or equal to 9, I plus plus. As I already told you, what I'll do is helper of ans cur plus I, and this should ideally work. So I'll just call vector int ans. This will be helping to maintain the state of a number, and I'll just call helper of ans, cur number being 1, n being n, and I'll just return ans. So I'll just make it void, because that ideally won't be returning anything. So what, I'll just check it with some layer numbers, like 3. I'll just check if car plus I is less than n. Helper and car plus I. Yeah. If it's not, I'll just take this out, because that's not needed in that case. I'm not sure why this is taking more than expected. I mean, why I'm getting this additional 3 over here, it should ideally not be the case, right? So the error in here is like, we are trying to just, if we just consider the example that we were checking earlier, right? So obviously, if it's at 1, then it also will be processing from 1 to 9. And if it's, for example, 2, then also it will be processing from 1 to 9, right? So if it's 1, then adding 1 plus 3 would give us 4. And if it's 2, adding 2 plus 2 would give us 4. So that's why we could see many 4s over here. So to mitigate that, we'll just simply say, here only I'll do for int I equal to 0, I is less than or equals to 9, I plus plus. If my current number into 10 plus I is less than or equals to n, what I'll do is helper of ants current number into 10 plus I in. So what I'm checking here is like I'm just checking if I'm gets given a root. I'm just checking if my current number into 10 plus I is less than or equal to n. Then I'll just proceed to that branch or to that tree. If it's not the case, then I'll just break if that's not the case, because anyhow I'm just incrementing. So for every possible higher number, it won't be the case. So I'll just break it out. And this is for one particular branch. So I just need to call it for all digits from 1 to 9, because this is for only one digit. For int I equals to 1, I is less than or equals to 9, I plus plus, helper of ants I n. So this should ideally be working fine. Yes, it's working as expected. So I'll just try to help you with the help of an example. I mean, give an example. So if I just consider my n to be equal to 13. So if n is equal to 13, first is n equal to 1. So all the branches or all the subtrees to the left side of which fall under one root should be solved first. So if that needs to be solved first of all, what I'll be doing is n equals to 1, right? So I'll just check if 1 into 10 plus I is currently 0, right? So 10 is less than or equal to 10. So 10 is always less than or equal to 10. So I'll just process 10 first. And then 10 would be processed. And if that case, helper of 10, and in this case, 10 plus 0 is less than or equals to n only. But 10 into 10 is there, 100, which is greater than n. So this would be broken and this would be coming up. And if it came up, then only, I mean, already I equal to 0 is processed. So it's retraced. And if it's retraced now, the current state I would be 1. So I would be 1 being processed now. So if I equal to 1, then that would be 10 into 1 into 10 plus 1, which is equals to 11. So 11 is less than or equal to 10. So 11 would be processed next, and then followed by 11, n equal to 12, 12 will be processed, and n equal to 13, 13 will be processed. So after this, with one subtree, I found out every number, right? So I'll just find out for 2. And I mean, being 2 as a root and all the subtrees that are part of 2 being 2 as a parent, I'll just find out all the numbers possible. So that's how this works. And for fairly reducing the time taken, I'll specify my C++ compiler not to import any libraries from C. That will be helping me to take input or give output anything to the terminal. So I'll just call cin.tie to be null, followed by cout also not to tie anything. So I'll just try submitting this out. Yes, it's working fine as expected. Feel free to add anything in the comment section if you think anything is unclear. Thanks a lot for watching the video.